So we got exponents and we got powers of 10. Okay, so we're going to be talking about that. When you multiply tens together, like 10 times 10 times 10, the product is called a power of 10. You can use an exponent to show a power of 10. The exponent tells how many times to multiply 10 by itself. So in this one, 10 by 10 by 10, how many times are we multiplying? 3. So we can write 10 to the third power, and that will say I'm taking 10 and multiplying it by 10 times. The reason we do this is especially when you get into science and scientific notation, and you're looking at really small numbers or really big numbers, it's way easier to say something times 10 to the 47th power than to write that really big number, right? Because I can write 3.2 times 10 to the 47th power. That's a little bit. Or I'd have to write 3.2 written followed by 47 zeros, and that would take a long time. And when you're doing big calculations, it helps. So here's my standard form, 10, factor form 10, exponential form 10 to the first power. It's just 10, so we're not multiplying 10 by anything. Here we have 100, 10 times 10 is my factor form of factors of 10, and then my exponential form is 10 squared, so 10 squared equals 10 times 10, which equals 100. Here, if I'm following my pattern, this is 1,000. 10 times 10 times 10. My exponential form is 10 to the third power. Here I have 10,000, so that's going to be 10 times 10 times 10 times 10. And that's 10 to the fourth power. 1, 2, 3, 4, 4. 100,000, there's 1, 2, 3, 4, 5 tens. And this would be 1 million, which is 10 times 10 times 10 times 10 times 10, or 10 to the 6. Isn't it just much easier to write 10 to the 6 instead of 10 times 10 times 10 times 10, or even 1 million? This is 1, 2, 3 digits. This is 1, 2, 3, 4, 5, 6, 7 digits, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. So way simpler method, way more efficient method, and as mathematicians we do enjoy to be efficient. Multiply each whole number by powers of 10 using the steps shown in the example. So here's this, 43 times 10 squared equals 43 times 10 times 10, in parentheses, equals 43 times 100 equals 4,300. So they're wanting us to show the factor form, so you can use this up here, of our exponent, do that multiplication inside the parentheses, and then multiply. So I have 79 times 10 cubed, which is 79 times, and in parentheses, my 3 tens, which is equal to 79 times, up here I can look, which is 1,000, or I can just do the math in my head, and then this is 79,000. 79 groups of 1,000, 79,000. So if we look at 79 times 10 third equals 79,000. We know that this 79 is shifting down 3 spots, 3. So my 7 goes from the tens here, it was in the tens, and it shifted down 3 spots. 1, 2, 3. My 9 was in the ones, it shifted down 3 spots. 1, 2, 3. 105 times 10 to the second, all my digits are shifting down 2 spots to the left. That's 105 times 10 times 10 in parentheses, which is equal to, 105 times 100, which again, I'm shifting down 2 spots. Where do these zeros come from? Well, my friend, 105 can be written like this. All of these numbers can be written 105.00000. There's an infinite amount of zeros over here. And so these zeros, where was this zero? It was in the tenths, and then it shifted. Got it? Okay. 4,568 times 10 to the fourth. Woo, this is going to be a big number. 4,568 times 10 times 10 times 10 times 10, which is equal to 4,568 times 10,000. How many spots are my 4, 5, 6, 8 shifting? They're shifting 4 spots. What's replacing these 4 digits are zeros. So I can do how many zeros? 4 zeros. So I'm going 4, 5, 6, 8, 0, 0, 0, 0. Every 3 spaces I have a comma. 1, 2, 3. 1, 2, 3. So 45,680,000. So let's check that. My 4 was in the thousands, which is here. It should have moved 4 spots. 1, 2, 3, 4. Perfect. And if that 4, 5, if the 4 moved 4 spots, everything else moved 4 spots. And where were these zeros? They were here. They were in the tenths, the hundredths, the thousands, and the 10,000s. All right, and then we got 17 times 10 to the 5th. 10 times 10 times 10 times 10 times 10, which is 17 times 100,000. 17 groups of 100,000 will give me 1.7 million, right? So my digits should shift 5 spots. So what is that? 1, 2, 3, 4, 5. Yeah, that was in the tens. So that shifted 5 spots. Cool. Multiply each decimal by powers of 10 using the steps shown in the example. So again, same thing with this. That's why I did the zeros to the right. That's where these zeros come from. So if I have decimals there, they're moving that way too. Because again, if you think about adding zeros, if that's what you think, that's not what's happening, then you make big mistakes when it comes to decimals. That's when the killer is. Because you will do things like